My guest today is Oren Eini. Oren, how are you?
I'm very well, thank you very much.
I know your name, but tell us, what do you do?
I'm the founder of Hibernating Rhinos. This is a company that deals with basically data. This is how we started. We built a profiler for entity framework for the inhabit Oren. A whole bunch of other stuff, but those are the only things that remain current. And after a long time with working with people to actually get their inhabit entity framework applications to work better, I got so frustrated with the notion that, okay, I see so many good people trying so hard and just failing to get things done because the database in the middle was so obnoxiously in the way.
Oh,
yeah. So
that's a shame, because almost every application I've written over the last 2 or 3 decades involves data.
Yeah.
Saving data, retrieving data.
Absolutely.
It's a huge part of application development.
Yeah. So the problem is that I'm going to bet that for 90% of your career, maybe 5% in the beginning, 5% in the end, the database that you used was always a relational database.
I'm used to that. I was a FoxPro guy, right?
Yeah, okay.
So I grew up with relational databases, absolutely.
Yeah, so the problem with doing that is that as long as the data fits a relational mindset, everything works.
Right.
And if you go back, 30 years ago, when VB was just a new exciting language, then the complex UI that you had was the master detail form.
Right.
And for master details form, the relational database is perfect because this is how you think. This is how
absolutely.
everything works.
You got your record at the top and then a grid below or something like that.
And
Every
that's
time you change that record at the top.
Yeah, and that's that. Now, the problem is what happens when you have more complex systems. And right now, if you look at, you don't almost never see a proper master details anymore. You see complex pages showing tremendous amount of data.
Right.
And let's take, for example, an order. I go to a supermarket and I want to buy a pair of shoes, whatever. And so I go there and I have an order, and the order have a list of line items, and I have discounts, and I have and I paid with $5 that I had in my wallet, and $20 on this card, and $20 on that card, and stuff like that.
Now what's the parent? What's the child?
No, not only that, but now try to imagine that I need to print out those this order.
Right.
So how many tables do I need to touch?
Right.
If you consider something as simple as Northwind, the Northwind sample database has the order table. If you want to actually spell it, you need to touch about 6 to 7 tables. And that's literally the simplest relational database you can imagine. And when you're talking about production systems, and I haven't touched about taxation at all, but that's important part of orders. And an order could be sitting in a few dozens of tables, and that's a huge problem.
Yeah.
Now that means that, let's say that you're a web developer, you're tasked with doing something simple. I want you to be able to go to the website and print me an order based on my customer ID and the date that I made a certain purchase. And suddenly you realize that you need to now spend a few days just figuring out how to access the data efficiently. And the more complex our application became, the more we needed to rely on patterns in our software. So we're talking about object-oriented, we're talking about domain-driven design, we're talking about a lot of stuff that we have to do in order to manage the complexity.
Right.
But at the same time, if the relational database is still there and is still forcing us to use the same 30-year-old modeling techniques, that hasn't changed because they are very deeply rooted into the schema of the database.
Sure.
Then there is a huge impedance mismatch. So ORMs try to help that, but they don't really do much because there is only so much you can do from the outside. So I was very involved for about a decade with the Hibernate project. And at some point after
which project?
With the Hibernate project.
Hibernate, okay.
Yeah. And at some point I decided that, after the profiler, after I I used to go to companies tell them, okay, this is how you properly write an ORM application. This is how you write a database-driven application to make it actually best utilize the database.
Right.
And eventually I wrote a profiler so I could do that in an automated fashion. And it still wasn't good enough because people still hit that impedance mismatch. So at that point, I sat down and I designed what I thought would be the ideal database.
Okay.
And the idea was that, honestly, I just couldn't get it out of my head. It was just bzzz. Yeah. So I said,
Great ideas are born.
yeah. So I said, okay, given that most of the customers were been in business application, OLTP, stuff like that, what would be the perfect database for them if I was starting from a clean slate?
Right.
And what ended up happening was that the design was a document database. That means that you can store documents, you can store object graph as a single document. So
Okay.
the older example from before, as complex as it would be a single document.
Right.
And that means that modeling concerns are now much easier. If you go into your business stakeholders and you start talking about, okay, we need to do the table design and stuff like that, they will just look at you with glazed eyes.
Yeah, they don't understand table
Yeah,
design
if
or
you
relational
go- if
databases,
you
but they
take-
understand
Yeah.
their business object or their business
if
model.
you take an A4 page and you put it on the table and says, right here how this should look like,
Right.
then you can, in most cases, you can do a one-to-one translation into your object model in a way that makes sense to the business.
So now you own essentially one table.
Yeah.
Take your entire object and just dehydrate
Yeah,
it and push
exactly.
it into a
Now, if you
database
have
as in the same structure.
relationship and complex interactions,
Right.
then you take 2 pages and you write, here is, this is the customer document.
Okay.
Here is the order document.
Right.
Now you have 2 physical things on the table and you can start, okay, what are the interaction with them? Wait, if I'm updating something here, do I need to update stuff here? Oh no, this is a one-time record. This is the customer address as it was when it generated the order. If the customer changes the address afterward, it doesn't touch the order here.
see.
So all stuff like that you can suddenly speak in a physical fashion.
Wow. So document databases do have relationships between tables.
Depending on which document database and depending on what you mean. Yes.
Okay. RavenDB does.
Yeah, sorry.
Well, your document database does. It sounds like.
My document database can allow you to define relationship, but
see.
they are much more ad hoc. And the basic idea is that in the order document,
Okay.
you have a customer ID property, and from that you can navigate to you can. In a relation database, you would navigate to the customer itself.
I see.
In a document database, at least with RavenDB, what happens is that you don't navigate. You have the customer ID and you load that customer. Now, we support features that allows you to do that only in a single remote request to the server. So you say, okay, give me this order, and along with this order, I want you to include its customer. So what happens is that you get the order, you also get the associate customer, and you don't need to worry about being chatty with the database, and it doesn't impact the object model with which you work. And that's huge because that drastically simplifies the amount of work that you have to do. It also means that think about doing a code review on a piece of code, and you say, okay, I see that here you load the customer, and then you load the order, and then you load the customer, but you forgot to include that. So you add the include and you just move on.
You don't have to go back and change the schema.
You don't have to change the schema. You don't have to change the rest of the code. It doesn't change the output that you get from the server. Everything works just the same. The idea here is that you don't need to. Another problem with schemas is that when do you define the schema of a database? Typically, first day of the project, you sit down, you have you do some analysis, you build a schema of the project, you build a table, whatever, and now you can start working. And that's the time that you have the least knowledge of the system. You have no idea what you're doing yet, but that's the time that you start putting the foundations to the system.
Right.
And because schema is such a hardcore concept,
Right.
changing the schema is such a big thing.
Right.
Just look at all of the migration libraries that you have
Now
out there.
we have tools
Yeah.
to assist that because it is
Yeah.
hard.
So that was the basic idea with RavenDB. Now another thing that was very important for me is that um, I think that one of the primary differences between being a Windows developer and being a Unix developer or Linux developer for a long time was the expectation of quality of tools. So when I'm looking at, okay, I want to build a system on Windows, the level of polish on the tool tends to be extremely high. If I'm looking at, I want to build an application on Linux, even if this is a very well-trodden path, then the level of polish of the tool is generally much less. Let me put
I
it.
did not know that.
Think about it this way, okay? If Microsoft wants to put up a new language,
Right.
okay, it will put it up when it has a ID and a debugger and probably a profile of some sort.
Right.
And there's a lot of taxes that Microsoft pays whenever it needs to put up something.
And often that's all integrated into Visual Studio.
Yeah.
Because that's our
And
core developer
if
tool.
if someone else wants to put up a language, let's talk about something like Go, for example, then the debugger is JDB, or sometimes I think that only now they started having what I would call a real debugger. And if you look at certain features such as multi-threaded debugging in Visual Studio versus anything else. So when I started working on RavenDB, I looked at the landscape. And the landscape was that there was a lot of NoSQL databases, and it felt like you go into your NoSQL database, and then you start when you start the car, then you start by cranking the shaft, and you had to remember 16 different things to do, otherwise it would backfire and do stuff.
I see. Okay.
Like the engine is all you're sitting on the engine, and there is nothing nothing in the middle. You're sitting in the middle of the engine.
Yeah. Microsoft had two advantages. One is it's a big company.
Yeah.
And two, they already had Visual Studio as a starting point for the
Yeah.
IDE, for example, and
Yeah.
a lot of the
So-
architecture around the plugins.
So what I wanted to do with RavenDB was I wanted to give you that same feeling. That meant that link support. That meant that it's transactional. That meant that doing a lot of work to make sure that things made sense. That things just worked. For the most part, I think we did very well there. Not always on the first try, but I think we did very well.
Okay.
And what we did now is for the past 2.5 years or so, we have been busy working on the fall release of RavenDB. And we had two goals there. One of them was that we wanted to be able to run on Linux. And the second thing is that we wanted to be 10 times faster as we are now.
10 times. That's
Yes.
pretty ambitious.
Yes. And luckily we had the core CLR coming out.
Because
and
it's cross-platform. Runs on
yes,
Linux.
yes. So right now we are actually able to run on Windows, Linux, and Mac.
Oh, nice.
Yeah.
In release, not preview.
No. We are currently doing an RC release
Okay.
at the end of this month.
Okay.
In October, November we have the actual release.
Oh, that's right around the corner.
Yeah. And the fun part about this was that because we decided to make those two modifications at the same time, we didn't just migrate the code and call it quits.
Right.
I don't think that we would have been able to do that. RavenDB is,
Yeah.
I don't know, hundreds or millions of lines of code.
Wow.
Hundreds of thousands.
Yeah,
or
and
millions of
.NET
lines of
Core
code.
is it's a major shift in the .NET
Yeah.
framework as well.
But because we ported features, and one feature at a time, and that meant that we had the advantage of, okay, now let's look at that, and now let's look, because the idea here is that we were able to look at the feature and not just as a design on a whiteboard. We know how people are actually using that because it's out there. So we decided to say, okay, when we move this feature, let's redesign how it works. Let's fix that. We made a lot of modifications to the way that we do things.
Mostly with an eye toward optimization and
Yeah.
speed. Is that the idea?
Yes. Coursera itself was a major shift of that because in the .NET days, if I found a problem,
Mhm.
then my issue with that was that, okay, I can report it to Microsoft. 18 to 24 months later, I might have a fix. If I have the appropriate support contract, I could get, an MSI with a hotfix for that.
Yeah.
But I usually couldn't distribute it to my customers. And right now, I can, two things that happen with the open source stuff is one, I have the code, I can go and fix the code if I
Do
need
a
to.
pull request and actually change
Yeah,
it.
and I can also talk with and that was just huge. I
Yeah.
can talk with the people who actually write the code and talk to them about this. Now, some of those things are too minor to actually matter to anyone but that particular scenario. For example, when you call stream.copy2, it allocates a buffer.
Okay.
That buffer is about 80 kilobyte in size, and if you need to call copy2 a lot, that's horrendously inefficient.
I see.
Now, no one cares.
Yeah,
Whoever
calling it
needs
once
to
is still a big deal.
Yeah.
Calling it 1,000 times.
Yeah.
that's
So
start to feel
the problem is that now I can go and make a PR for that, and there's a high likelihood
Pull
that it
request,
will be
yeah.
accepted, and that goes in. And in the next version, there are stuff that's going in, and that means that there's all of these incremental changes that happen, and none of them are super major.
right.
But it gets to the point where there is an avalanche of features that become much faster. One of the things that I think that was really amazing for us, we do a lot with encryption and hashing and all sorts of stuff like that in order to be highly efficient. So one of the things that we need to do in many hashing functions, there is the notion of rolling right a value, rolling the bits
Okay.
some amount of bits to the right. Now there is an assembly instruction for that, and unfortunately the JIT used to output more code for doing that than was
So
necessary.
just-in-time compiler.
Yeah. So we talked with the G team, and they added code that would recognize that, you want to use this rolling right. Let's just output this specific instruction, which is much more efficient. Yeah. Today we are talking about. We just got a new benchmark machine, and this benchmark machine costs about $1,000. It's not a month or something like that. In our standard benchmark for the past year or so was Stack Overflow. So Stack Overflow has something called data exchange, where you can get all of the data from Stack Overflow. So we took all of the data from stackoverflow.com, which is roughly 18 million documents.
Makes sense. Popular site.
So yeah, it's actually more than that, but we condense some of the things into. So there are 18 million questions, and I don't know how many answers, but lots. And
Half of them are that one guy, John.
Yeah. So our current test is how fast can we import Stack Overflow into RavenDB. The current answer is 5 minutes and 6 seconds.
Wow.
Now
For
that's
80 million documents.
18 million documents and 52 gigabyte. So that translates to about 60,000 writes a second and about 200 megabyte per second on a sustained basis. Then
On basically a home computer, a $2,000
yeah,
computer.
no, $1,000
$1,000
computer.
yeah, so
Yeah.
not a super cheap one, but
Yeah.
certainly not a
Yeah.
workstation style.
Yeah. Now on a actual production machine, we're able to sustain 100,000 writes per second on a regular basis. Actually, not quite. For the first 100 million writes, we're able to sustain for the first 50 million, 100,000 writes per second. After that, we drop to 60,000 writes per second.
It gets faster as time goes on.
No. It's, yes, to a point, but at some point we run out of memory.
Oh.
So we drop to just 60,000 writes per second.
I see.
and at some point
So
we
it
ran out
doesn't
of
get
disk
cached
space.
as much.
Yeah, yeah, but
So is that did you achieve your 10 times performance increase?
yeah.
What was it before?
yeah, I think that the max that we were able to do is about 15,000.
Wow.
And the problem with that was that, and that's also really interesting. Problem with that is that it was very spiky, and the reason for that is that we had to allocate a lot of memory. If you allocate a lot of memory, you can defer some of the costs for a bit, but then you have to do a GC, and a GC cycle can basically
GC is
power-
garbage collection.
Yeah, and that's going to pause your application, stop the word collection. And if you have a stop the word collection, that basically means that your performance goes like wee boof.
Oh, every time you do a GC,
Yeah.
then that happens.
So one of the things that we did is we move a lot of our allocations into native memory. And that means that we allocate some memory from the operating system.
Oh, so that means you take care of your own garbage collection.
Yes.
And it's
And
unmanaged.
then the amount of memory that we currently have on the scenario we are handling 100,000 requests a second, we are typically allocated between 600 to 1 gigabyte of memory. While handling a database of, I think it was 150, 200 gigabyte under very heavy write. And that's very stable number. That means that when the GC runs, it doesn't have to run over a lot of memory. It means that it has lots less work to do. It means that it doesn't need to power so much. Yeah, so that was a very, very good performance. And a lot of those decisions now feed into one another.
Sure.
They reduce the memory utilization, reduce the management utilization, means
Okay.
that the GC doesn't have so much to work. That also means that we have more control over our memory, which means that we can have higher locality and reduce the amount of overall allocation from the operating system. That also means that we have much better chance of working with the operating system in many cases. One of the really fun things that to discover or to build was that we don't actually need to write a lot of code to get things working properly. All we need to do is to make sure that you set things up properly and let the natural behavior of the system to take you where you want to go. So, for example, with GC, if you only have very, very short allocation or very, very long allocation and nothing in the middle, because we took ownership on the stuff in the middle,
Okay.
that plays very well into how the GC thinks about the world. So that means that you reduce the work for the GC. If you're working with memory map files, then you can rely on the operating system itself to manage what is in memory and what is not. So you can just delete the caching that you need because it's already there.
I see.
So you need to make sure that you don't need to do any work to read from the memory map file. You don't need to parse the object or to materialize that. But once you do that, then it's very cheap to actually get some data, and the operating system will do a lot of work for you for free, basically.
Yeah.
Yeah.
Very nice. Well, this is a lot of information here, and I love the fact that you put all this work into migrating to .NET Core, taking advantage of the features of .NET Core, improving .NET Core itself with pull requests, improving the resource management, and it runs on Linux and Mac now.
Yeah.
That's a huge upgrade for an established product that you've had for, what, 10 years? How long?
10 years. 2009 we started development. 2008 we started design. 9 development. 10 we had a production
Okay,
release.
so we're coming up at the end of the decade here, so it's a pretty mature product.
Yeah.
And especially to do something major like that.
Yeah, it's a huge change. 2.5 years with a team of 30 people. It's major pivot for us to go there.
If people want to use RavenDB, where do they go? Where do they get started?
RavenDB.net.
Okay.
If you're using Docker run RavenDB/RavenDB and you have a RavenDB instance,
Okay.
and that's the easiest way to do that.
Tell me a little about the cost model of it.
We are an open source project. We are free for commercial use as long as you're running on a single node. If you're running on multiple nodes, then you need to purchase a commercial license.
Okay. And then learning about it, is ravendb.com the best place to
No,
go?
RavenDB.net.
.NET, I'm sorry.
Yeah.
If that's the best place to go to actually learn how to use this, or is
Yes.
there another resource out on the web somewhere?
Yes, that's the best place.
Excellent. Oren, thank you so much.
Thank you. think that one of the things that I'm most appreciative of is that I got to work on technology in the field of technology, and I actually got to work on what otherwise would be my hobby. And I think that working in technology with a bunch of good friends, seeing all of the really cool stuff that we can do is really, really satisfying. And I'm sorry, I'm sounding very much in the air and spiritual. So it's fun. Technology is fun.